Good afternoon. In my notes it says good morning, but we all know what happened. I'm Juan Moreno Cruz. I'm Assistant Professor of Economics at the Georgia Institute of Technology. And what I'm going to do now is 5 minutes just to introduce myself and the type of research that I do. Goes without saying that my research does not involve necessarily the institution of SRMGI. But I just want to tell you what I do. I work on SRM firstly because I didn't like it, like Andy said. But now I work on it because it is very interesting from an economic perspective. I have worked on climate change economics for a long time, and geoengineering, or SRM, changes everything. Everything that we knew about how politics and the economics of climate change work changed when we introduced this technology. And why change? Because geoengineering has very different characteristics to traditional mitigation. It is cheap in the sense that relative to mitigation, it can be implemented by a small coalition, like Andy was saying. It is quick, which means we don't have to act fast, even though we are in danger. And on something, if something turns out to be worse than we were expecting with the climate, then we have this tool that could reduce the impacts of climate change. So with that background, my work considers 3 different questions. The first question is, how do we use this tool, this technology, in an optimal way? So abstract from all the politics that are associated with the implementation of a global technology, and let's figure out, just based on costs and benefits and risks, what is the best way to use this technology. And we have different alternatives to use this to deal with climate change. It's not only mitigation and SRM, we also have adaptation, and if we don't do any of those things, then we're choosing to suffer. And by we don't mean us, the world is choosing to allow some amount of suffering in the world due to climate change. So we have really 4 options, and we need to learn how to mix them. And of course, this is very theoretical, because we really are not so certain about the risks and damages of geoengineering. But under certain assumptions, that we can come up with an idea of whether there is an actual role for geoengineering. Again, abstracting from all the politics. Is there a role for having a technology that has the same characteristics as SRM? My research says yes, there is, but it's my research, and you're welcome to criticize it. And many other people have said the same. When they add termination effect, then the likelihood of SRM being used optimally is reduced. But if there is a role, an optimal role for SRM to happen, then we need to step back and say, okay, if it happens in this ideal world and everything is better, what happens when we move away from this ideal world? What happens when we understand that this is going to happen in an international and planetary scale? Yeah. And when you start to look at SRM in those terms, we realize, and this is what new simulations show, is that SRM, while reducing the average temperature very well, it does not reduce temperature equally in all parts of the planet. It does not alter precipitation in the same way in all the parts of the planet. So some countries are going to benefit more from the implementation of SRM than others. And if that is the case, then some countries are going to want to do more SRM than other countries. I'm from Colombia, so suppose that it's getting hotter in Colombia, I want an amount of SRM, but it's not as hot as it's getting in Jamaica. So Colombia is going to want an amount of SRM that is lower than the amount of SRM in Jamaica. And then, like Andy said, who picks? What is the temperature that we're going to use? And then economics allows you to actually think through this problem from a game theoretical perspective, and that is the other part of my research. I try to understand the geopolitics of SRM using game theoretical tools. So suppose that we don't know how to do this, and by this I mean how to deal with these geopolitical problems and the new geopolitics of climate change when you do SRM. Then what do? We have two alternatives. We come up with a structure and we allow a subset of countries to do it, or we decide collectively not to do it. But if we decide not to do it, remember, we're deviating from the optimal position, which was maybe using it a little bit. So now we're saying we're not going to do it. And that by itself is a choice. And it's a choice not only for regions today that will benefit from having a small amount of SRM. It means that we are also leaving the future generations unarmed in case climate change gets out of control. And that is what leads to my third question, which is intergenerational transfer and intergenerational equity. We have, and as economists, I cannot talk about ethics because I don't have any, but from an economist perspective, we need to start to understand this from a risk-risk trade-off. So we're talking about a future generation, and we're going to tell them, you have to deal with the risk of climate change, and you might do this with SRM or without it. But if we leave them the technology, which means start doing R&D today, start doing research today, we also are leaving them with the possibility of a technology that is risky. And just as Sandy was saying, there is no easy answer to this. There are many questions, and economics allows us to think through the questions, but not to give us full answers. And for that, we need more research. But the important thing about this, and this is what I do and what was my interest in SRM, is that whatever we choose has implications with respect to this technology. And we know enough about the climate. We took notice, no? And we know also a lot about SRM now. And we need to know, well, not enough, but a lot. And we need to make that an informed choice, and that's why we're here. So that's it. Thank you.